Yes,
Dr.
sir.
Ganesh Balamurugan? Yeah, we can
Yes,
start
sir.
now, isn't it? Yeah, fine, sir. We can.
Okay, sir. Uh, Morning, madam. Please start.
Start பண்ணிடும்.
Good morning, everyone. Ladies and gentlemen, let me first thank the Lord Almighty who has preserved and protected us. Warm greetings to the excellent intellectuals, professors, faculty of various universities and institutions gathered online today for this CSIR sponsored online 2 days national level seminar on challenges and opportunities in 3D printing and design. This program is organized by the Department of Mechanical Engineering, IFT College of Engineering, an autonomous institution in Viluppuram, Tamil Nadu.
The way to start a successful day is to have a warm welcome. I now invite Dr. K. Ganesha Balamurugan, coordinator of this function, IFET College of Engineering, to deliver the welcome address. Over to Dr. K. Ganesha Balamurugan.
Thank you very much, sir. Good morning to all dignitaries, staffs, and participants. This is an immense pleasure to welcome you all on behalf of the Department of Mechanical Engineering to our 2 days seminar on CSIR sponsored challenges and opportunities in 3D printing and design. I'm glad to welcome our respected chairman, Mr. K.V. Raja, the nucleus of the driving force in pursuit of excellence. I cordially welcome our secretary, Mr. K. Shivaram Alva, the motivator, passioning as we reach greater heights. I cordially welcome to our treasurer, Mr. R. Vimal, dedicated in the mission to transfer knowledge. I also welcome our principal, Dr. G. Mahendran, and vice principal and dean academics, Dr. Matilda. All for this seminar, almost 135 participants have been registered, and this seminar is about 3D printing. So why we have chosen this topic? Because 3D printing is the present and future. So it ensures the design freedom, which makes a paradigm shift to the present society for future endeavors. We are fortunate to have an eminent expert in this field as speakers. Mr. Kumar Ramajayam, CEO and President, Bytes and Boards Labs, USA, Mr. Anand Kumar Mishra, Operations Manager, Three Textile Education Private Limited, Dr. Manila Ravishankar, Associate Professor, Department of Mechanical Engineering, IIT Tirupuri, and Dr. Manivannan, Scientist, Additive Manufacturing and Metrology Group, CMERA, CSIR Group. We are honored to have their lecture in this seminar. Dear participants, I assure you, this seminar will surely delight you, and at the end of this seminar, you will gain a fruitful knowledge and understanding about 3D printing. Once again, a cheerful welcome to all professors, faculties, and students of various universities and institutions to this online knowledge enhancement program. Wish you will all enjoyable online learning experience. Thank you. Uh, I have to give one information. Uh, Please, everyone should mute your videos and the audios for uninterrupted presentation for everyone. And at every end of the session, we will share our attendance in a Google form in CSC in our WhatsApp group. So kindly you have to fill it for the certification purpose. Thank you very much.
Thank you, Dr. Ganesha Balamurugan.
I now invite Professor P. Velmurugan, HOD Mechanical Engineering, IFT College of Engineering, to deliver the inaugural address. Over to Professor Velmurugan.
Good morning, all. I think I can be heard. Fine. So good morning all. I feel very privileged to be a part of this 2 days program on 3D printing and designing sponsored by CSIR. 3D printing, also known as additive manufacturing, is a method of just I have is a method of creating a three-dimensional object layer by layer using a computer-created design. So 3D printing is an additive process whereby layers of materials are built up to create a 3D part. This is just the opposite of subtractive manufacturing process where a final design is cut from a larger block of material. So as a result, 3D printing creates less material wastage. So this technology is already changing the way we produce objects from tools, toys, clothings, or even our body parts. So as a spare. So the spectacular thing that has happened in recent day was 3D printing was extensively used in building up the rocket that was launched by the SpaceX. So additive manufacturing also allows designers to create complex parts for machines, airplanes, and cars at a fraction of the cost and time of standard means like forging, molding, and sculpting. Now, smaller consumer-friendly 3D printers are bringing additive manufacturing to home and business. So, which is further adding on to the fun of engineering. In olden days, 3D printer was preferred to create prototype mostly using a photo polymerization technique. So dating back to 1920s. So thanks to the evolution of the laser technology, which dramatically changed the applications of the 3D printing from prototype to real-time manufacturing. So the advantage of additive manufacturing is that there is no process planning required as in the case of conventional manufacturing, and even more advantageous only if the product is intricate in nature. So it is advisable to go for conventional manufacturing method if the product is simple in nature with respect to the shape and material. So the real challenge lies in the additive manufacturing, producing the part with lesser lead time, printing the metals and alloys with no defects. So our students even took up this challenging opportunity as an academic project. So one of our students printed the biodegradable water bottle few years back. So the difficulty he faced was to print the 250 ml bottle. So in those days, it took almost 1 day using this FDM technique. So for the past 2 years, our students have been trying to build a low-cost, customized 3D printer using e-waste. So and uh, actually we are indebted to our speaker today, Mr. Kumar Ramajayam, for having rendered this support by offering internships to our three of our students. So who have
It's okay, sir. We can proceed, sir. You can proceed. I think I have got a break. Okay, okay. Thank you, Professor Velmurugan.
It's time to begin the first session of this CSIR sponsored online 2 days national level seminar on challenges and opportunities in 3D printing and design.
Now it's time for introducing our resource person. I now call upon Professor Ilamalidi to introduce the resource person, Mr. Kumar Ramajayam, CEO and President, Bytes and Labs, IEEE Southern California Council, and Chair STEM Educational Outreach Programs. Over to Professor Ilamalidi.
Good morning to all. It is my privilege to introduce Mr. Kumar Ramajayam, CEO and President of Bytes and Labs, IEEE Southern California Council, Chair STEM Educational Outreach Programs. Mr. Kumar Ramajayam had a short teaching career at the University of California, Irvine, and California State University, Long Beach, in the field of educational technology and information systems. He then worked in IBM for 9 years. Mr. Kumar Ramajayam became an entrepreneur in the year 2009. He is the founder and chief education officer of Bytes and Bots. He is currently involved in the following enterprises and educational activities. IEEE Southern California Council Chair STEM Educational Outreach Programs and co-chair of International Science and Engineering Fair, ICEF 2020, Anaheim, California, and Anaheim School District STEM Program and Service Advisory Member, and a member in Association of California School Administrators and Partners in Educational Excellence Award winner. STEM Advisory Board member of IVC, OCC, and Saddleback College. Mr. Kumar Ramajayam is provider of Makers Lab and custom 3D printers. He has been a California resident for 3 decades, and Mr. Kumar Ramajayam interest includes mountaineering, grape growing, and winemaking. He is a certified wine educator and a sommelier. So we are very happy to have such an eminent person with us today. Thank you, sir.
Professor Elamarudi. I now invite Mr. Kumar Ramajayam, CEO and President, Bytes and Bots Labs, IEEE Southern California Council, Chair STEM Educational Outreach Programs, to take over the session.
Hello. Hi, thank you, everybody. Do you need my video, or video is not needed?
It is up to you, no problem, sir.
You can share. We are always welcome.
All right. Okay. Very good. So thanks, everybody. And for me, right now, I'm in California in our lab in the city of Irvine. The time here is 8:50 p.m. It's just after dinner. I'm joining all of you. It's a privilege and honor to talk to all of you and share my experience in this industry, 3D printing for education and innovation. I just wanted to ask a quick question. Oh, but can I start the presentation of my PowerPoints? One second, let me do that.
Yes, sir. You can share your screen and start it.
Okay. Are you able to see the screen? Oh, one second. One second. Okay. Are you able to see my screen?
Yes, sir.
Yes. Okay. Very good. Just wanted to find out how many of you are. Are you all tuning in to this presentation from Tamil Nadu, or anyone from outside of Tamil Nadu, and you don't you feel comfortable with my language? Is everyone English and Tamil speaking, or we also have other language speakers in this?
I think most of the majority of audience are from Tamil Nadu. We are able to understand.
Okay. All right. Okay. I'm not going to go over the videos. You can Google them and watch them. What we're going to cover in this presentation, what is 3D printing? In the intro, some of the faculty members talked about that a little bit. With the focus on education and innovation, how 3D printing technology has been evolving and are being embraced and used by individuals, hobbyists, educational institutions, from elementary to secondary to post-secondary educational institutions across the world. And it's the inherent nature of supporting how it enables curious minds to make new things and take an individual's creation to global market across the world. We'll talk about that. Some basic information about the different types of 3D printers, what are the different components of a 3D printer, and what can you do with it. Since I'm talking to all of you from California, this is holiday season, Christmas and New Year. There are stores. I'm sure one of the popular gift items parents will buy or aunties and uncles will buy for their children will be a 3D printer from a local tech store so that the kids can draw stuff on a computer and then print it and play with it and have fun with it. That being said, let's move on to our own lab. From an idea that you conceive and you digitize that idea by using a CAD software and saving that off in a file format and printing it. So this little short video here is showing.
Let's get some practice designing a machined part like the one you see here. Now you can see that for the most part, it's made up of extrude features, which added the geometry and removed geometry for the pockets and cuts, as well as some fillets to break the sharp edges. Now let me switch over to this other part studio to get started. For this example, I have a sketch already created. The two-dimensional geometry here can be created in Onshape using the various sketch tools and constraints. But for this example, I'd like to show you how you can leverage a sketch like this that contains multiple sketch profiles to create the 3D geometry for the part using various features. To get started, I'll extrude the main body of the part. I'll make sure all of the sketched geometry is deselected and select the extrude icon from the toolbar. I'll select the interior profiles to create the geometry for the body of this part.
I'm going to fast forward that for a moment. So let's move on to this video. So here, digitization of your idea of a product creation using a CAD tool on the computer and then sending it to the printer. So whether it's a coffee maker or a cup, or say I have my pair of glasses and I wanted to personalize and use my own design to design and print the frames for my glasses, I can do that in a few hours and make a one-off product that is designed and created for my glasses that fits my face profile the best possible way. And that's pretty cool to do. And you don't have to be an engineer. You don't have to know everything. Just you're able to Google most of this and even download an existing file and modify it. If you have the computer-aided drawing skills, then you will be able to print it and wear that on your face. The next example, we have a 6th grader in one of our labs where she's doing biomimicry in this. And that bionic arm project was designed digitally and then printed, and then she programmed using Arduino and open source hardware. I'm sure many of you are familiar with that. And what has done this for this young girl that is working in our lab, it has inspired her to become a future engineer, that not because her parents told her that she should study engineering, but because she became interested because of 3D printing technology, and she understood it is a pretty cool and fun thing to do. Okay, so let's move on to some of the other examples in different industries. And in fact, you are able to see right behind me, there are a couple of 3D printers that are actually printing right now. Right there, there is a 3D printer that's printing an object, and it'll run overnight and print. I'm not sure what it is printing. I would have to ask the engineers, but it is doing something right now. Okay, so let me go back to, I'm going to show you a 3D printed V8 engine model. So it's a time lapse, and it's showing it at a higher speed of the whole extrusion of and building and print as it is printing it. So the end product here, after it prints, and here is a functional prototype of the pistons, and with a simple drill that they are simulating that. Again, how cool is that? And then another quick Toyota car company's model. Somebody earlier during the introduction mentioned that it is used in the space station. It's used in space technologies. It's used in every aspect of life, anywhere from making some fun toys to serious one-off production quality that you can actually use it and fix issues. So I'm going to pause this. So again, a few years ago, this will require a lot of fund, a lot of resources, people, and their time in order to make a one-off functional prototype to test something. So for me, this is an amazing thing that has happened from our traditional manufacturing world. How many of you have made a Ganesha statue for Ganesha Puja? yourself, or you just go to the market and buy a clay model of Ganesha. And that is an example of traditional manufacturing, making a statue of Ganesha using clay, or making a pot that you use for cooking. And then you move it to the next level for industrial type of mechanical engineering type of applications. And in the picture that you see how complicated and unwieldy heavy equipment and machinery are needed to manufacture materials, prototypes even, whether it's functional or non-functional prototypes. And the amount of waste products that get extruded when you are making traditional manufacturing used applications, you will have a lot of debris, an environment that is not clean. And it causes pollution. These materials can go add contaminants to water resources and our land. But with 3D printing, you can specifically design, and because it's additive nature, you're able to reduce all of those pollutants in the environment. So dirty manufacturing is becoming history. Now, what's in a 3D printer? Well, for a beginner, and that's my topic here, and you are using this in the world of education. Say you're in your college and you are teaching an engineering subject or a product design subject, industrial manufacturing type of subject, where instead of talking about all of the dimensional aspects and the physical and spatial aspects of that project, you can actually quickly ask them to draw it on a piece of paper in an analog format, and then evolve that on the next step to digitally design it using a CAD software, and then quickly print that object and test it. And when you are studying business MBA programs, they talk about a concept called fail forward. Fail forward is very much possible. And in fact, you can quickly fail and quickly fail forward so that you learn from your mistakes and you are able to update the design, make it more viable, correct all the mistakes or errors, and then make your product in the first 1 or 2 cycles a close to finished functional product. Okay, so and it is using very simple components as part of the 3D printer machine. You can make a 3D printer machine in your own house. In fact, here a lot of people in their garage workshop, they have a little garage. Garage means typically in America, you park your car, you have some repair or change your oil in the car. You're able to do that in your garage, in your workshop. You don't take it to a typical car mechanic shop to do that in most cases. Okay, of course, as we Indians that we live here, we don't want to get our fingernails dirty, so we don't do that, but most Americans will do it. It is a garage-based culture. So 3D printing has enhanced that, and it is a beautiful thing. And their kids also join the dads doing that in the garage, and then say, okay, let me also join you doing that. So engineering that natural involvement of students, young children getting involved in the making process. And then how is it relevant for innovation? We'll also talk about that. And there's a little anecdotal story that I wanted to talk about that. Okay, so as part of the 3D printer machine, there's an extruder assembly, and there's a hot end nozzle. Let me actually walk over there to show you that. Hopefully the camera can. You probably have seen it. And let me see. So on this, so there is a printed object on the hot plate. This plate here is the plate where the layering occurs. And here is the extruder assembly. I hope you can see it. Here's my hand. I can show you that. And then the filament is coming from here. There are different colors you can switch. And nowadays there are 3D printers where you can have multiple colors extruded via multiple nozzles here. And then also you can see one that is printing some sort of a specific component for a research and development project. Okay, so this lab all around here has different types. So here's an R&D. Somebody's building a 3D printer here using some locally sourced materials. And there are different types of 3D printers. I hope you can see that. So this is a Delta type of 3D printer that is being built in our lab as a prototype, meaning a printer to print a printer. And that's pretty cool. There's actually a Hollywood movie actor that said once, here are some more. So I'll go back and take my seat. So that person said, go to the store, buy a 3D printer, come home, print a 3D printer, and then return the 3D printer. Does that make sense? I think that is pretty cool. You buy a 3D printer, bring it home, and design your own 3D printer and print using the 3D printer, and then return the original one that you bought in the store and then get the money back. Of course, that's possible in the US. You can return things and get full refund, but in India, you may not be able to do that. Just a side note. Okay, so that's I thought that's pretty fun. Let me go back to. Okay. Are you all able to see my previous slide that I was talking about? Then, but instead of the picture, I actually showed you the printers where it's printing and some are being assembled. So there is also the brain part of this 3D printer, which is a controller board, and where you can customize it. You can write your own code and upload to it. And make a 3D printer that suits to your approach and your lab or whatever purpose that you're doing that printer for. And any moving locomotion aspect, the X, Y, and Z traversing of the nozzle head or the extruder assembly, they're all provided by the stepper motors and the stepper motor controllers, and the operation of the pulleys and wheels and belts. So there is a controller, and we make our own controller in our lab, and modeled on an open source specification. And again, as you saw, some of these specific aspects of that. And the different types of 3D printers we have, Cartesian, Delta, Polar, Scara. You saw some of these models as I was walking around the lab and showing them to you. And what about the nozzle size? So that the layering, the slicing of the melted extruded materials, so that you can have the fine grain control of the printed object. And here's a little animation. So there's a motor, hop gear, heat sink, and there's a thermistor to sense the temperature, because it has to, the thermistor will provide the control for the temperature control and manage the temperature. And by the way, I was in India. A few years ago, I visited all of the major 3D printer manufacturing companies in China. And also from an end user point of view, there's a place in Auroville where somebody got a 3D printer. And then another industry there's an industrial estate near Pondicherry I visited. And guess what? They have 3D printers, and they were very happy that it worked for the first 3 or 4 projects. And after that, it got stuck and nobody was able to fix it. And they got tired of it because it never worked after that. That is a major problem when it comes to 3D printer. It's not like your regular paper printer. You use the laser printer where you can print something on a piece of paper, and even somebody that doesn't have any technical skill or knowledge can open, change the papers, and put the ink cartridge, and you can continue with the business of printing. But in this one, 3D printers need, on a regular basis, proactive cleaning, especially the nozzle. All of the frozen materials will clog up. And that means if you're not interested, if you're a regular user, then you are stuck. And that's exactly what I saw. And a lot of my friends here, they actually bought a 3D printer for their kids. And like I said, it prints a few objects. And after that, it gets dirty. And then the printer is not being used. So you have to be a lab monkey in order to actively use it and work it so that you find the benefit of it. Coming back to that slide trip on the consumer-based 3D printer use and what happens to that one in the market. Like I said, you use a hardware and then typically written in C, and you have a controller program that provides the brain and logic function, controller function for your 3D printer. Okay. You can buy a 3D printer here in California anywhere from like a, $75, $80 for your kitchen countertop use versus multi-million dollars, where you can print a beautiful pair of shoes. Nike, the company, the shoemaking company, they are investing big time in printing shoes with the right amount of air pocket, so it provides great cushion. You can design, they will send you a template. You can go to Nike's website and draw your feet using that template, and then upload that design of your feet, both of your left and right foot sketch, and then they will make the specific pair of shoes that work for your feet. And what is that? And that is what Industry 4.0 is. And we'll talk about that a little bit in one of the later slides. Now coming back to when you print an object, It is not going to print things in the air. It is needing some sort of a support, especially there are some overhangs. You're printing a tree. It has leaves that are hanging, but those leaves need to be extruded and layered and printed. So it will print supports for that. And then later, as part of the post-processing, you will remove those. And then the slicing is controlled. Slicing means every individual micro level layers with the right amount of fills so that you can control the density, strength, etc. with that. So filling is something that you need to control. There are job opportunities where 3D printing companies, bureaus, hire people that specifically work on what type of fill is needed in order to efficiently print a prototype. Okay. And here is a one-off that needed the support. So you wanted to print this nut, a screw, and so you need to design that and then also tell the 3D printer, oh, you need to have these types of support so that the extrusion will go smoothly and you will have the end product for that. And you have to configure that like you will configure regular printer to do that. In the printer configuration software interface, you can do that. And let's talk about the different types of materials. There's PLA, ASA, PETG, some of the popular materials that are used, and it's showing the examples, how much strength it can take and when it'll break. Your typical elemental strength analysis, all of those things can be done with the amount of power test that you do. And there's also a long list. I heard even recently they are sourcing coconut fiber from India and the Philippines, and they are using that as part of the extruded material and making that so that you can make environment-friendly materials. And this slide shows some of those examples. When it comes to prototyping, prototyping for industrial use or prototyping for your own personal hobbyist or fun use, all are possible. Remember at the time, when you went to the tailor, say I'm 55 years old, back when I was in Tamil Nadu, before I came to the US, before I went to college in India, when I was, say, 7th grade, before Deepavali festival, my dad will take me to the store, the streets in my hometown, and we'll buy the fabric, the cloth, and then you'll go to the tailor, and the tailor will measure your body, and then he'll say, come back after 1 week, and you will get your custom fit, custom tailored shirt and pants. Now, you can do that to design, customize your own car that is street-worthy, meaning that you can drive on the road. It is not a fun, cool toy that the kids play. It is actually you and your family that can sit in the car and drive on the road and get to a destination safely and get back home. And that is called individualized mass manufacturing. What is that? Individualized mass manufacturing. How creativity and innovation can play a major role. creativity and innovation can feed into that cyclical, perpetual creation of more creativity and more innovation. Okay, so remember I said you go to the tailor and he measures your body and then he custom fits that particular shirt and pair of pants that you wanted to wear, and that's individual need, right? You are making your own shirt by paying that tailor who measures your body and does that. But as we move from that, that is, I'm talking about almost 2 generations ago that happened, but it is coming back. How is it coming back? Because of 3D printers. Because 3D printers can individualize at the same time mass manufacture. A student from your college, your university engineering department can dream up a beautiful product that solves a day-to-day problem. And he designs it and he can 3D print, and then he can scale it up and mass manufacture it and sell it to the world. And then go to the next step is, okay, so now you wanted to customize my generic type of product with your own logo, with your own name, maybe with your picture, and you can let people do that customization, which is fun for them to do. And how about this? You can actually 3D print a dosa or a birthday cake, and say your son or daughter is having a birthday party, and you can we have a 3D printer that can print pancake. Pancake is roughly the equivalent of dosa in South India. And it prints pancake based on the design that you created on the computer, and you uploaded it onto the 3D printer's controller program. And then now you have a customized pancake with, say, a star or a bunch of balloons flying on that with different colors embedded, that is creamy layered and that is still edible, and it makes that kid feel happy because it is highly personalized, and then it is individualized, and you can also mass manufacture that. And then when I visited one of the biggest manufacturers of 3D printers in China, Tier Time is that company. The amount of emphasis and the encouragement the government gives. Xi Jinping personally visited the inauguration of that company, and they are providing enormous amount of support in quality manufacturing of the 3D printers, including metal 3D printers, because they are focusing on intelligent manufacturing. So we talk about additive manufacturing, rapid prototyping, or advanced manufacturing. But what about intelligent manufacturing, just-in-time manufacturing? If on the space station, International Space Station, a particular part is broken because Elon Musk's company shipped a couple of 3D printers and they are sitting there, and all that they have to have is a design uploaded from Earth, and then the astronauts on the space station can print and fix the problem. It could be the hinge on the door or a nail that came off connecting two sheet metals. You can make that happen, and you don't have to worry about the door flying off into the space. So that is the power 3D printer gives people, anywhere from any individuals, even children, small children that are learning math and science, you can do that. And how can you use this to teach math? It is all about geometry, right? 3D is geometry. And mathematics is the expression of symmetry. So symmetry is the key in mathematics. So if you are able to connect that concept and make them design that on the computer, they will readily understand without going into the theoretical memorization, and they will be able to actually print that and see it function, and you have the aha moment. And that student will never ever have to memorize mathematical formulas, and he will be able to learn it hands-on. That is, I call it hands-on, applied, real-world based learning. You don't have to lecture them using a whiteboard, but you can rather have them discover, fail forward, and become an innovator, become a problem solver for a better tomorrow. And this example, the European Space Agency actually used this a functional, it's not a prototype, it is a production one that was actually used as part of the liquid rocket engine, and that was completely 3D printed and used. And here are the spec on that. You can Google it and you can find that. I think India is ready and prime. It is in its prime state to get it to the next level. But our task from schools and colleges in India is to promote by using a functional, a couple of 3D printers that you can build it inexpensively, and say college students can help high school students. High school students can help middle school students and elementary level school students. And similarly, the professors and expert faculty members of universities can help their affiliated college faculty members, and they can interact with inspiring and introducing, giving in the form of giving workshops, etc., to the high school, middle school, and elementary school teachers. So from ground up in India, we can build innovation culture and using a hands-on applied STEM, science, technology, engineering, and math type of a learning model. I hope it makes sense, and it is very much doable, but the only thing is that Indian institutions have to support it. I think we are ready, and the government, I believe, is trying to do everything. And let's talk about another vertical market where biomedical devices, say I was in San Jose in the Bay Area. There is a specialized company that uses, say, when you are a medical student and you are going to the anatomy lab, and the actual dead bodies, cadavers that are being opened, and it smells really bad when you go into an anatomy lab, and you actually get to touch and feel and put that body back, and you become a doctor. What about that? So that at one point you actually need that, but before that, you can actually use a 3D printer to create a model of, say, your heart, or a specific type of valves in the different sections of your heart, and then you can specifically zoom in and focus and highlight the different parts so that it is easier for them to learn. And so you can make medical dummies, medical dummy body parts, or even a functional body part that can be created. And currently, as you probably have read that in the newspapers and science journals and magazines, these are actively in the works that are being done. What about spacesuit? Spacesuit is extraordinarily expensive. It used to be very difficult to manufacture, but these days, with the 3D printers' help, we are able to custom measure that astronaut and then print all the necessary parts and weave them together and create that custom suit. There's a case study. There's a company called a bunch of MIT students got together and they formed a company called Desktop Metal. They are using a special technology where similar to FDM, and they are able to print one-off parts with enormous time saving benefits and material strength benefits. In every aspect, they're able to do that. So I told you how innovation that seemingly sounds silly, but the sillier the project is, not very serious. Oh, like a mechanical engineering professor in India would say, oh, just focus on this special electrical car engine or motor that you wanted to do. And they will directly go in there and work all of the algorithms and the logic behind it, but without ever touching that, actually making a prototype in the, first off. But whereas in the US, the culture is, I told you at one point, is a garage-based culture. So you first start with failing, making things and failing a few times, so that from the beginning you're focusing on quality, and your success in making innovative products are high. So there was one project that was done in MIT that I got to see. A student, many times. Let me go to video, because right now I'm talking to the screen, hoping that I'm actually being audible, etc. So. The problem in that project, that innovation project, was many a times you feel like screaming, right? But you cannot scream because it is offensive to others. Maybe you're in a public place. Sometimes now, even with the COVID, you try to control your sneezing or coughing, or blowing your nose, etc. So this girl in MIT Media Lab wanted to create a screaming machine. And what is that screaming machine? She thought the problem, like I was describing, whenever you feel like screaming, you should be able to capture the scream in a bag and then let it out at an opportune time and place. So she created a kangaroo-like pouch. Thank you, Dr. Balamurgan. So like a kangaroo, the animal from Australia, she created a custom pouch, and she used 3D printers to make a lot of the parts for that, and also used Arduino, the open source hardware, and started the project. And whenever she felt like screaming, she'll open the bag and she'll scream into it, and then close it. And it had all of the mechanisms in that product. Then later, whenever she found the right time and the space where it's not going to bother others, and she'll push a button and it'll open and the scream will come out. Eehaw, whatever scream that is, that the screaming machine, that's what it does. Now, does it have a commercial value? But it has a cool factor. It is fun. Just imagine somebody captured somebody's scream and then it lets it out, and you're able to control the time and space for that. And the amount of science and technology, engineering, and the promotion of innovation that happens in that project is huge. Okay. So that being said, I would like to open up the presentation for questions and answers. You can either type in your question, or you can unmute yourself and ask the question, and somebody can moderate that.
So, how can be the effectiveness of the normal FDM filters available in Amazon and Flipkart is there? Whether they are useful to purchase and to make as a teaching material?
So I believe your question is when you buy a printer from Amazon, right? Typical FDM printer from Amazon. And I heard that clearly. And after that, what happened?
Can we use it for teaching purpose? That is to teach how to make the 3D printing and 3D printing process to graduate students?
Yes, my recommendation is yes, start with that. And I'm sure it's going to be made in China for sure, because they make everything for the whole world, even now. Start with that, get a couple of 3D printers, and then I'm an Indian. I love India. And what I would like to do is what the Chinese did always. What did they do? They took pictures and then they recreated everything. And now they are in a place where they don't have to take pictures, and they have started making high quality products. So we missed that boat. I mean, we tried at one point in Mumbai, and like when I was 20, 25 years old, it happened actively. But the duplicate market like Burma Bazaar and all those places got inundated. But right now it is our turn. Yes, buy a couple of 3D printers, like I said earlier, and then start making, let your students make them. In fact, you just buy two and make them, disassemble one and take it apart, and then make them put it back. And then these guys will be ready to make their own 3D printer using local materials. And I have seen it. I have seen your college students do that, and I was very proud of recalling that experience. And that is one of the things that we did, and when we hired the interns from your school.
Next one, sir, from my side.
Yeah.
What are the research opportunities in 3D printing, especially polymer 3D printing? Because it is saturated, I think. Is there any opportunity to do research further in this polymer-based 3D printing?
Dr. Balamurgan, the voice is kind of mumbled.
Can you hear now, sir?
Yeah, if you can speak up, maybe.
Okay,
speak
sir.
up.
I will again ask.
Yeah.
What is the research opportunities in polymer-based 3D printing? Because most of them are tried, I think it is not fully established. Is there any opportunity to explore more, that is to do research in polymer-based 3D printing?
I actually knew a professor that I worked with in SRM University, and his focus was on optimizing the polymer technology for 3D printing. And he was also working with the students using recycled like plastic waste products everywhere, collecting them and then repurposing and making 3D printable like pellets first, and then later the pellets will become extrudable wire spools. And that was the research that he was doing. So my answer is yes. What I would do, again, that is a nice project. Since we are still using a lot of plastic and waste and stuff, and I would strongly encourage having a bunch of students do research and have a competition around that. I can even support such competition through some sort of an award at the end for good ideas or good say prototypes that they can make.
So when they want to do research in the polymer 3D printing, what would be the range of the machine to be purchased or procured for this type of research? Because we are academicians, mostly we are concerning about research and teaching. So what is the range of the machine is required for effective research to polymer 3D?
Yeah. I'm sure we can have a separate conversation around this.
Okay.
I can even connect because I'm not I don't go into, I'm at the managerial level, so I'm not able to go into the lot of technical aspects of it.
Okay.
Thank you. Anybody else?
One question. Yeah, I have one doubt.
Yes.
Hello, is it audible,
Yes.
sir?
Yes, Surya Varman, right?
Yeah, sir.
Yes.
Yeah, for a student community, which type of printer you prefer most, sir? Whether FDM based or SLA based, which one you prefer for a student community to use?
Start with either one will work. We have tried in the beginning. It's both are similar approach, similar concept, so it'll work. But FDM is less expensive, right? SLA is a little bit more expensive. What is the current market availability there? I believe Creality printers are the ones that are being flooded into the Indian market, right?
Yeah, sir. Most widely FDM is available in everywhere, but other type of decision method or deposit or jetting type of printers are not.
Yeah. So if you don't have any, I will put priority one. Your first will be FDM, and then go for stereo approach, where it cures liquid polymer in a tub and then extrudes from that. Because it's more expensive. Obviously, the technology is more involved in that. We have worked with the local university here on that. But FDM is my first step that I would do if I were you.
Okay, thank you.
You're welcome. Anybody else? All right. So Dr. Balamurugan, if there are no other questions, I wanted to thank all of you for this opportunity to share my experience and knowledge.
Sir, I have one question, sir.
Yeah, yes, Saravanan.
Sir, is there any chance to print complaint mechanism material by using 3D printer, sir?
What mechanism are you talking about?
Complaint mechanism, sir. Complaint.
Can you give me an example?
Example. Before, at the starting of this presentation, you have video on playing, sir. You played a video, that hand movement video.
Oh yeah, yes.
It's also an example of complaint mechanism, sir.
Okay, I'm not sure that word that you are talking about.
Okay,
Yeah, so there is a lab in New Hampshire in the U.S. They focus on. Are you talking about complex structures?
sir, it's a flexible mechanism, sir. Complaint mechanism is also otherwise called flexible mechanism.
Oh, okay. Yeah, so you have to print modular parts, and then you have to stitch them together. It's a little bit laborious. So what we try, you have humanoid robot, right?
Yes.
Robot that can walk. We have actually done that. It'll be unwieldy. In fact, we took a Hollywood actor and then recreate that actor, facial structures and all of this. But very, very involved, to do that. But you have to modularize every segment and then put them together through some sort of joints assembly system.
Okay, sir. Thank you, sir.
Yeah.
Sir, one of the participants asking permission to speak with you. Can we allow him?
Sorry. What was the comment there? Comment or question?
Max Cab Hero. Can you please speak? Unmute yourself and speak, please.
If possible, I can answer that question, sir.
Sure, yeah.
Last question, sir. Sir, actually, the complaint mechanism comes under the topic design for additive manufacturing.
Okay.
Parts for in the process of additive manufacturing, this process helps us to create mechanism inbuilt in the design itself. For an example, we got a cloth clip. Cloth clip components majorly, the top part and the bottom part and a metal spring. So by compliant mechanism, we can create an internal stress so that we can simply print a component and it can work like a cloth clip. And this mechanism is used in satellite navigation system, where we have nozzles, right? So in order to reduce the amount of electricity that we use in satellites, we can implement this compliant mechanism, and with one motor, we can control the X and Y direction of the motor. So this is a very good work. I couldn't remember the university which does this, but in design for additive manufacturing, this topic is a very interesting topic that we can develop a lot of components in this regard. And when we use the printer, we got the pass function also, where we can add another infill so that we can make those parts also work in a better way.
Beautiful example that you gave. Okay, so George Mason University, for example, the muscle in your heart, they are specializing in biomechanics. It is used there quite a bit, but the challenge is the material that you use for that. They're even specifically culturing those tissues and then those are tissue cultured and replicated in the lab, and then that gets extruded to make that muscle, and they are testing those in the medical world and biomechanically, especially biomechanical. And thanks for adding that information. Now it makes sense to me. Yeah.
Sir, I am Santosh
Yeah.
Kumar, sir. I have one doubt, sir.
Sure.
Sir, which type of 3D printers are used to build a human organ, sir? Is possible?
Again, it is at the R&D level. Like I said, George Mason University, they are working with pig's heart, and what they are taking those tissues from the heart of the pig, and they are tissue culturing it and then growing it in the lab, and then they are using that with special biomimicking materials to do that. It's at infant stage right now. That is my understanding. But it is custom. The material itself is custom manufactured in order to make that.
Okay, sir. Thank you, sir. Sir, which type of 3D printers are used, sir?
Again, those 3D printers are specialized 3D printers. It wouldn't fit into any of these categories that we are talking about currently. See, 3D printer technology has been there for a long time. So the patent licensing requirement by 3D Systems, that is the main company that owned it, that expired, and then it opened up the whole world of everybody trying that, and then open source folks got in and popularized it. So, but a lot of secret work that is happening, and they are not being published, and they are not even available on the internet because these funds are funded by pharmaceutical companies, and American pharmaceutical companies are closely guarded. It's a multi-trillion-dollar industry across the world, and they are betting on making these specialized 3D printers. I'll tell you, HP, that makes your paper printers, and they are putting in billions of dollars into making 3D printers, becoming a mass-produced, consumer-consumed type of technology. And they are going to sell little cartridges where you can actually, the printers will behave like regular paper printer. So, but they are not publishing until it becomes a readily commercially viable product. But we know that they are doing that research as we speak.
So, thank you, sir.
Yeah.
Thank you very much, sir. Very valuable information you are giving. So thank you for giving this very informative presentation for us. Thank you, sir.
Ganesha Balamurugan, this is Manimaran.
Yes, sir.
Hello. This is Manimaran here, sir. Is it possible to print biodegradable plastics product without in an economical way?
So the one that say the U.S. schools are very much into health, right? So the bioplastic material is what? Which one is that? SLA, the material that I showed. All these print materials that we use here. Let me bring that. So this uses the material that is an acid from a plant. It is an acid-based material, and this is closed environment, air conditioned. When it is printing, it doesn't cause any bad smell, does not create any fume, no health issues with this. So when we have students come to the lab and learn and print, we are only allowed to use this. Any other type of anything other like other materials, you're not allowed.
Thank you, sir.
Yeah. All right, very good.
Yes, sir, I have one more question, sir. This is Session1, sir.
Yeah.
Will a 3D printed object superior in strength when compared with conventional products, sir? What about in strength perspective, sir?
So that is a lot of people are doing their PhD level research on tensile strength, malleability, ductility, those elemental analysis type of things. And that is where every university, major universities are focusing on material science. Material science that will research and develop the materials that are going to give optimal strength needed in specific temperature, right? For example, if you are putting a 3D printed material on the space station, on one side, it is facing one side of the space that is about minus 200 degrees Celsius. On the other side, it is plus 200 degrees Celsius. So one side it is almost melting, the other side it is freezing, and the material has to withstand extreme such variation, temperature variation. So that is the reason material science is one department where a lot of active research is happening in the US, and funding is also getting pouring in. HP, like I said, how you can make 3D printers that can be mass consumable, consumer friendly, like regular paper printer, and where's the money being spent on the research? Material science. So you take the elements in the periodic table and make a concoction. Remember, we were making trying to make gold out of a bunch of plants. சித்தர்கள்லாம் சொல்லுவாங்க, சித்தர் மெடிசன்லாம் பண்றது அந்த மாதிரி. The material science is hot right now, and if I had the money, I would definitely go to that, but it is an expensive thing. Private companies, even very big companies, in India cannot afford it. It has to be a frontier research. Frontier research means start with theoretical fundamentals, understand the elements in the periodic table, and then how to make a concoction, and then how material science R&D will be able to filter that out and say, oh, you make these three elements in this formula, then you can print a specific component that'll work in X, Y, and Z temperature condition and variability.
Thank you, sir. And I have one more question regarding actually business point of view.
Yeah.
And what is the scope of doing business with 3D printer? Is this the right time to invest on 3D printers to do certain business in Indian perspective, Indian market?
Yeah, I was actually thinking about making, you have malls, shopping, big supermarket. Is that in Chennai? There's a place called the Phoenix Mall. In Pondicherry, there are some big multi-level places. And now there is a consumer market for, mehendi, the henna, right? Henna?
Yes, yes.
Mardani.
Yes.
So I would like to make a 3D printer that'll apply Mardani in beautiful designs. They can draw their own picture, what type of thing that they want. Right now, they had to go to what is that place? The popular ladies only places are there. Women go there and get their mehendi done on their palms and on their feet. But 3D printer can do it. They just have to go, like they go to a salon and you get your makeup done. And similarly, the 3D printer can do that. So Indian market is ready for that. Some of your students should start doing all of these, including your dosa printer. Like we have your pancake printer. I think it'll become a nice micro loan. Banks can provide loans, but you have to just standardize it and then provide ongoing technical support, because these things are they need constant maintenance, because it works with temperature, it melts stuff, and then especially the nozzle gets dirty, and that needs to be maintained, like I said before. So business opportunities are plenty to me. It's not, you're not going to have a precursor, right? I mean, precursor meaning you're not going to be already seeing an existing business. You're going to create a new business and then create that new market. So you will be a trailblazer and pioneer in doing that.
Thank you, sir. Thank you.
Yeah, and it is not expensive either to do that.
Thank you very much, sir.
Thank you, everybody. I enjoyed talking to all of you.
Thank you, sir. You should. You also.
Thank you.
One more, sir.
Okay.
So
Thank you, Mr.
Yeah. So then I will disconnect, and thanks everybody.
Yeah, 1 minute. Thank you, Mr. Kumar Ramajayam, for having spent your precious time with us this day, especially the time difference between US and India. If you are an early Tibet timer, you would have gone for sleep by this time.
Yeah.
Thank you very much for having spared your time, precious time for us. Your lecture was fully informative and educative, and no doubt that all the participants would have been benefited. Thank you once again. Thank you very much.
Thank you.